Hi everyone, welcome back. Let's have a look at surds. What are surds? When we talk about root 2 or root 3, we're talking about what we call as a big category of surds. And what is that? So if I said I wanted some number times itself and I wanted to get 2, if I had a guess, I could have a guess at it and say I think that's about 1.4 or about 1.4. And when I multiply 1.4 by 1.4, I get 1.96. So it's pretty close to 2. Then I can go further and further and keep guessing. So I wrote down some numbers here. So for example, if I have 1.414 times 1.414, I get this incredible number, 1.999396, and I'm very, very close to 2. So this number here is called everyone knows it's the square root of 2, but when you start talking about surds and getting more complicated, it's like people forget what the basics were. You can put it in your calculator and it'll give you a lot more decimal places. I know it's about 1.4142, pretty close to that. And I could calculate that even without the calculator, and be fiddly, time consuming, and get what it is. I also know that if we're saying what number times itself will give us 3, so in that case it's root 3. Root 3 by root 3 would be 3, and I know that that's about 1.732. It's very close to it. And if I multiply that by itself, I end up with 2.999824. So this number is an approximation for what that is. But the surd is not the approximation. The surd is learning the rules about what can I do with these things when I don't want them as an approximation, but I want them as, and the big thing we're talking about is exact values. Interesting part with surds, we can teach it higher and higher and go lots of stuff, but in reality, in most of school level maths and even a lot of university level maths, we're only using the concepts quite simple. So I want to keep to the fairly simple concepts today and start talking about what do they mean. If I had the number of root 8, and it is a number, and I could put in my calculator and get an approximation for what that is. Now the moment I put in the calculator, it's an approximation. I could start to work out what it is. I know that 3 3s are 9, so I know it's going to be a little bit less than 3. So if 3 3s are 9, what times itself would be 8? Probably about 2.8 by 2.8. And if I wanted to guess a bit closer, maybe it's 2.9. I could keep guessing what the numbers are. But let's go back to the concepts of what's going on. Once we now know that's what a surd is, oh, by the way, before I forget, root 4 is not a surd because it turns out to be exactly 2. And by definition, surds are only the ones that don't turn out to be an integer or a whole number. So of course root 9 would be 3, so that's not a surd. So we're talking about all the, I could refer to them as yucky ones, but in real life you can put them in the calculator and they're not yucky at all. So I could rewrite root 8 as a root 4 times a root 2. And what I'm doing is breaking it down into its factors. Now some of you might remember, depending on what you've done in the past, that you have factor trees. And you can break the 8 down into 2 times 4 or 4 times 2. I wrote the 4 first because when I get to 4, the square root of 4 is 2. And all I've done here is rearrange square root of 8 into another form, which is 2 root 2. And I talk about all the time two things. One, that we can rearrange anything. And secondly, we learn something that we don't see the purpose for as yet. That's why I sometimes say maths is one of those things that I do refer to it as backward. And I don't mean as in it's got mental difficulties. I mean in terms of it's like reverse, and you don't see the purpose for it when you first learn it. Now, by the way, are a lot of people going to use surds in their life? No. But those who want to go to any sort of significant math level, there'll be surds all through it. And I can give you examples of those, but not right here and right now. So we can rearrange it now. Again, you're not seeing why you have to arrange it, but these examples I'm giving here, number 1, all we're doing is having a look at what numbers can rearrange and why. Here's another number I could rearrange, and what I'm looking for is the special numbers. And the special numbers are squares. And why are they special? So 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, we could keep going, 25 is 5 squared. Now in that number 12, I want to get my factor trees, or write it as a product of the factors. So I could break, most people look at 12 and break it down into a 4 times a 3. Let's have a look what happens with surds. The insides can break down, or if I was multiplying, a 4 times a 3 could become a 12. So I could rewrite the number root 12, because that's a root 4 is just a 2, I could write that as 2 root 3. Now if you want to put in your calculator a root 12 and see whether this is a decimal, if you want to put in your calculator root 3 and times it by 2, you can also see what that is a decimal and see what it is. Now a lot of the work now comes down to how can I rearrange these when I don't see a purpose for them as yet. So we're learning the rules of what can happen. So if I had the number root 18, see this one had a factor of 4. This one had a factor of 4. This one has a factor of 9. So we're looking for the squares. So this has got a factor of 9, so I can write that as root 9 times root 2. Go back to my factor tree, so I can say 18 is 9 times 2. A lot of people would write it as 3 times 3 times 2. So root 9 is just a 3, so that's a 3 root 2. So you could keep going with the numbers. I could get one with it. I want one with a 25. So a really obvious one with 25 would be 50. Because I could write 50 as root 25 times root 2. Then root 25 is 5, and that's root 2. So what we're doing is turning a lot of yucky surds, or square roots in this case, into a form where this number's smaller, this number's smaller, this number's smaller, this number's smaller. It does mean in some of our calculations when we've got them in the smaller form it's a lot easier to use them. So there's a bit of an introduction. Probably you don't see much of a use to it, but for those who need it and they know they're going to need it, especially if you're going into higher level maths or you're looking at higher level math courses or you're using surds already and you're not comfortable, maybe it's a bit of an understanding. Let's see what we can do with them in the next video. If you're enjoying it, please just let your friends know.